Hey guys, very quickly we're going to learn something very powerful, and that is your relative atomic mass. There are two subtopics that look very similar. We have relative atomic mass is different from relative molecular mass. Atomic and molecular, they are two different things. So we'll start with atomic, and the next class will be molecular. Are you getting me now? So in your relative atomic mass, this is our lesson 9 right here. Very simple. And we're going to go together and look at it in details. What must I know about relative atomic mass? What is it like? First, I'd like you to understand that for elements with only one isotope, in other words, elements that have one isotope, what happened? The mass number is the same thing as the relative atomic mass. Listen. Now, if we are dealing with your relative atomic mass, we're going to make reference a lot to mass number. Are you getting it now? Let's say, for example, we have an element X, right? This X here is the element. You can see that X is represented like this. There is A on top of it, and then there is Z underneath it, right? It's just like, for example, we have chlorine. Chlorine, here is 17, and then here is your what? Your 35. You can boldly agree with me that X here is the element and chlorine here is the what? Element, right? A here is equal to what? 35. So what is A called? A is called the mass number. What is it called? Mass number. What is it called? Mass number. And then Z here is called the atomic number. So if A is the mass number, can I call mass number atomic mass? Yes. Atomic mass is the same thing as the what? Mass number. And then yes, Z is called the atomic number. Atomic number is different from atomic mass. Atomic mass is something as the mass number, which is your A. Z is the what? Atomic number. Now listen carefully before I go on. Anytime you hear the word relative atomic mass, because we are dealing with atomic there, it means we are talking about elements. We are focusing on elements. When you talk about listing relative atomic mass, because of the atomic, what are you dealing with there? Atom, elements, is different from your relative molecular mass. When they say relative molecular mass, molecular, you have now entered compounds. Relative atomic mass has to do with what? Elements. Relative molecular mass has to do with what? Compounds. Now listen carefully. For elements that have one isotope, what happened? The mass number is equal to the relative atomic mass. That's elements with what? One isotope. But there are other elements that we choose not to have one isotope at all. Now, for elements that have multiple what? Isotopes. Give me a good example of elements with multiple isotopes. Like, for example, let's say your chlorine, for instance. Right? Your chlorine, we have chlorine 35, and we also have what? Chlorine what? 37. You can see that the isotopes are different. So, chlorine has multiple isotopes. So for elements like chlorine now that have multiple isotopes, what happened? The relative atomic mass is a weighted average based on the isotope masses and their abundances. So relative atomic mass for them become your what? Your weighted average on the basis of their what? On the basis of their isotope masses and their what? Abundances. For the last time, elements that have one isotope, what is their mass equal to? Their mass is the same thing as their what? Atomic number. But elements that have multiple isotopes, what happens? The relative atomic mass for them, which is your RAM, is a weighted average on the basis of their what? Atomic masses and their abundances. If fire me this question, popular Jamb And Waec question. And the beautiful question all the way says, for an element that has only one isotope, element with just one isotope, how is the mass number related to the relative atomic mass? If you have just one isotope, what will happen to mass number and relative atomic mass? They are the same thing. It means mass number is the same thing as the relative what? Atomic mass. Look at option A. Mass number is always twice the relative atomic mass. It's not true. Option B says the mass number is equal to the relative atomic mass. You are making sense here. And then option C says that the relative atomic mass is always half the mass number. No, it's not true. And then option D says relative atomic mass is the square of the mass number. What is the correct answer? For an element with only one isotope, please, the mass number is related to the relative atomic mass because the mass number is equal to the relative what? Atomic mass. And that makes option what? B the correct answer. Does it make sense? Very simple, right? Kajiko, yeah, let's go. Now, you must understand the concepts that govern isotopes. Oh, yes. When we talk about isotopes, the big question is, what are isotopes? Very simple. Isotopes are atoms with the same number of protons, but different number of what? Neutrons. Same number of protons, different number of neutrons. Same number of protons, okay, follow me. Let's say, for example, hydrogen. We have hydrogen 1, 1. We have hydrogen 2, 1. We have hydrogen 3 and what? 1. Now, listen to this very quickly. I told you that this guy up here, what is it called? It's called the what? Mass number or what? Atomic mass. And then this guy down, 1, 1, 1, 1, 1. You can see that all of them are related with their what? Atomic number. 1, 1, 1, 1, 1. That is down there, right? Oh, yes. How do I get number of protons? Atomic number is the same thing as the number of protons. Listen carefully. If here is your H, and then here is your 1, 1, here is your H, here is your 2, 1, here is your H, and then here is your 3, 1. All this 1, 1, 1 that you have down, what did we say? What did I say it's called? It is called your atomic number. What is it called? It is simply called your atomic what? Number. And if it is equal to the atomic number, what is atomic number? Atomic number is the number of protons that you have in the nucleus of the atom. I will teach that when we get to that topic, right? But please understand something here very easily with me first. If your 1 or 2 is the atomic number, what is atomic number? Atomic number is same thing as the number of protons that we have. So all of them are 1, 2, and 3. Do they have the same atomic number? Yes, atomic number is the same. Now, what do we say atomic number is? It is the number of protons. If you watch, all of them have the same number of protons, 1, 1, 1, or true. But they are different in the number of their neutrons. How do I know the number of their neutrons? Of course, the up minus down. That means mass number or atomic mass minus the atomic number. For the first one, what is number of neutron in this first guy here? For this first guy, number of neutron is what? 0. 1 minus 1 is 0. For the second guy, 2 minus 1, what will it give you? 1. 1 is the what? Atomic is the number of neutrons there. For the third guy, 3 minus 1, what will it give you? 2. You see, number of neutrons in all of them, they are different. So we can say that isotopy is the phenomenon, right? Where you have an atom with what? Same number of protons, but different number of what? Neutrons. Atoms of the same element have the same number of protons, but different number of what? Neutrons. What do we call that phenomenon? Isotopy. I will explain as we move, but not in this particular topic. Are you getting it now? It's a different chapter on its own. Now look at this very quickly. Relative atomic mass for elements that have different isotopes. Are you getting it now? How do we calculate it? It is calculated by weighing their masses according to their abundance. So how do you calculate your relative atomic mass? For example, let me just say helium now. Helium, right, is just 4 and 2. How do we get the relative atomic mass here? Very simple. Relative atomic mass here is equal to the mass number, and that is what? 4 is the correct answer, and you have moved. But in your chlorine, that we say, okay, chlorine 35 and chlorine 37 the relative atomic mass, you cannot just go and pick one out of the two of them. No. How do we calculate it? It is calculated by averaging their masses according to their what? Abundance. Are you getting it? And very importantly, look at another powerful question. The exam question here says, how is the relative atomic mass, right, RAM, of an element with multiple isotopes calculated? How do you calculate it? Option A all the way says by taking the average of the mass number of the isotopes. Average of the mass number of the isotopes. Option B says by averaging the masses of the isotopes according to their abundances, meaning you put the abundance into consideration. Option C says by summing the average masses of the isotopes. And then option D now went ahead to say by using the mass of one atom of carbon-12 as a reference. No, when you are referring to carbon-12, bro, we have entered another area. But first, look at me. We'll come to carbon-12 shortly. But please, how do you calculate relative atomic mass of an element with multiple isotopes? It's very simple. It is by averaging their masses, right? The masses of the isotopes in accordance to their abundances. And that makes option what? B, the correct answer. Now, I'd like you to understand this. There are elements that show isotopy, right? Oh yes. What are the various elements that have different isotopes? You must understand them as far as Jamb And Waec is very concerned. The first element there is hydrogen. Hydrogen has how many isotopes? 3 isotopes. Number 1 is called your protium. What is it called? Protium. You know, some people will say, sir, I thought it's called proton. Proton. Because proton is your H and 1 and 1. They play. Follow me from here. Proton is used in nuclear chemistry. Yes, it is different from your protium. Under the isotopes of hydrogen, what do we have? Your protium, number 1. Number 2 is called deuterium. Deuterium. Another name for deuterium is what? Heavy water. So deuterium is also called your what? Your heavy water. That's your deuterium. And then number 3 is called tritium. Tritium is the one that is radioactive. Which one is radioactive? Tritium is radioactive. When we get to radioactivity, I'll throw more light on that. Please, protium, deuterium, and tritium, not proton. You are wrong if you say proton. So number 1 element that undergoes isotopy, hydrogen. Another one is your carbon. Of course, we have carbon 12, carbon 13, carbon 14. Carbon what? Carbon 12, carbon 13, carbon 14. Carbon 12, carbon 13, carbon 14. The most abundance of them, of course, is your carbon what? 12. That's the one that is most abundance. Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb And Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons. You have access to your notes. You have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy. The third one is called your uranium. Uranium. Which one is uranium? Uranium-238 and uranium-235. Uranium-238, 238. We always keep using it to solve. Majorly, 238 is what we use majorly. And then uranium what? 235. These are the isotopes for what? Uranium. And then we also have your chlorine. Of course, you already know for chlorine, right? Chlorine is 2. Chlorine 35 and chlorine what? 37. And then we also have oxygen. Oxygen. What is it for oxygen? Oxygen 16, oxygen 17, oxygen 18. Very easy. 16, 17, 18. Come on, 16, 17, 18. That's oxygen. And then we also have your iron. Which one is iron? Iron 56, iron 57, iron 58, iron 56, iron 57, iron 58. All of these guys are the various isotopes that we have. I've given you what? How many? 6. So these are the isotopes of various elements that we have. If you understand this, bro, we're going to do some light calculations as we move, and then I'm going to see a lot of beautiful things. Please, I'd like you not to forget this, that in relative atomic mass, if you are to define it, how do you define relative atomic mass, RAM for us? But first, before I give you the definition, I'd like to draw your attention to 3 things that you must know under the definition of relative atomic mass before we even learn it. First thing is called relative atomic mass itself. That's RAM, right? Please, this is it. It is the way, right, that we use to compare the weight of one atom of an element to a standard weight. In other words, I want to get relative atomic. Okay, for example now, right, in biology, there is average weight for an adult. So a normal adult should weigh at least 70 kg. 70 kg is the recommended weight, right, for an adult. Physiological weight, 70 kg. That shows that, okay, you are healthy. Everything about you is all right. You should weigh 70 kg. That's an average adult. I'm not talking about a teenager. I'm talking about adults like 18 and upwards a bit. Now, what if somebody is now, let me say, the lady is 22 and she's now weighing, let's say, 53 kg. What will happen? You say something is wrong somewhere, right? Probably she's malnourished, she's not well fed, right? Or hunger, sackpad or the hula. These are the things that start coming into your mind, because why? There is a standard weight. And what's the standard weight? 70 kg, right? That's what we are making reference to. The same thing for relative atomic mass. It is the way to compare the weight of one atom of an element to a standard weight. So I know the weight of an element, I'm comparing it to the what? Standard weight. The question is now, what is the standard weight, right? Oh yes, that's where carbon-12 come in. So scientists use a special type of carbon. What is special type of carbon? It is called carbon-12. What is it? Carbon-12. You know we have carbon-12, carbon-13, carbon-14. Which one is the recommended carbon-12, right? Is what we use as what? Reference. And this carbon-12, right? It has a mass of how many units? 12 units. Are you getting it now? And then inside that carbon-12, there is what we refer to as 1/12 of carbon-12 mass. What did I call it? 1/12 of what? Carbon-12 mass. So to make the comparison, what we look at, right, is 1/12 of the mass of a carbon-12 atom. So this is your carbon-12 atom, right? Yes, very simple. And then I'm making reference to 1/12, right, of the mass of that carbon-12 atom. That is what I use as my standard for measurement. Oh, you feel. Now, what is the definition for relative atomic mass? Very simple. This is the one that you learn now. Follow me from here. This one must enter into you. Everybody wants to go. What is the definition for relative atomic mass? Relative atomic mass, RAM, of an element. Listen, when we go to relative molecular mass, it will be relative molecular mass, RMM, of a compound. That's why we use molecular. But atomic is for element. Want to go, what is relative atomic mass? Relative atomic mass, RAM, of an element is the number of times the average mass of one atom of an element is heavier than 1/12 of the mass of an atom of carbon-12. For the last time, what is relative atomic mass? Relative atomic mass, RAM, of an element is the number of times the average mass of one atom of an element, right, is heavier than 1/12 of the mass of one atom of carbon-12. Oh, you see, you can see that 1/12, right, of the mass of what? One atom of carbon-12 is coming in place there, because that's what we are using. The number of times the average mass of one atom of an element. Follow me. Want to go? Say it with me. The number of times the average mass of one atom of an element is heavier than what? 1/12 of the mass of one atom of carbon-12. What do we call that? Relative atomic mass. Why did I know it's relative atomic mass and not relative molecular mass? Because we are referring to elements here. Close your eyes. Want to go? What is relative atomic mass? Relative atomic mass, RAM, of an element is the number of times the average mass of one atom of an element is heavier than 1/12 of the mass of what? An atom of carbon-12. If you get this very simple with me, that means you can now flow. Take note that relative atomic mass has no unit. Please, what is the unit for relative atomic mass? It has no unit. I feel not you. What is the relative atomic mass for an element? It has what? No unit. Relative atomic mass has no unit. Why? Because it is the ratio of masses. And because it is the ratio of masses, for example now, okay, ratio of masses, let's say let's say, okay, you have 10 kilogram, for example, all over 10 kilogram. What will happen? Or let me say 20 kilogram all over 10 kilogram. What will happen? Can kilogram not cancel kilogram? If kilogram cancel kilogram, what is the answer? It is 2 that you have, just like that. Or you say like 2:1. So that's what you are going to have there. Very simple. You are putting the level of ratio. Relative atomic mass has no unit because it is the ratio of what? Masses. So their mass, the unit of their masses will cancel each other. So there's no unit for relative what? Atomic mass. Does it make sense now? For the last time, before I go on, what is the definition for relative atomic mass? Because Waec and Jamb will never forgive you if you miss it. It is the number of times the average mass of one atom of an element is heavier than 1/12 of the mass of one atom of carbon-12. If you get this very fast with me, let's go. Look at a Jamb Waec question. And the beautiful question says, what is the relative atomic mass of an element? Very simple. Option A, it is the average mass of one atom of an element measured in grams. Does they play? Option B says, it is the number of times the average mass of one atom of the element is heavier than 1/12 of the mass of one atom of carbon-12. I told you that you will always see 1/12 of the mass of one atom of carbon-12 there. You see this guy now, background making sense. Option C says, the total mass of an atom in a molecule of the element, just they do it in the play. And then option D says the mass of one molecule or the mass of one mole of the element in gram. What is the correct answer? Of course, option B is the correct answer. If you get this very fast, look at another powerful question that we're given. And the question all the way says, what is the unit for relative atomic mass, RAM? I told you. Option A says, okay, atomic mass unit, AMU is the unit. Option B says, no, it's kilogram. See, now we're trying to say, it has no unit. Is the correct answer. And then option D says, no, grams is the correct answer. What is the correct answer? Of course, it has no what? Unit. Option what? C become the correct answer. Does it make sense now? Does it make sense? Get this very fast with me. Please take note. There are things that you must know regarding relative atomic mass, and you must know the formula. You must know the what? Formula. In the next class, I'll be showing you the formulas that relate to relative atomic mass. When we look at the formulas, I'll show you one or two things there. Damn, we're entitled with a lot of calculations. Please run through this class again and ensure that you understand all I've just explained. Tell a friend that learning lifts, you are learning with it. See you in the next class. Enjoy. Bye-bye. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.